All right, in this lesson, we're going to learn about functions. Before we do, I want to show you some graphs to help you a little bit with understanding the idea of independent, dependent variables, the idea of something we're going to talk about today called domain and range. Okay, so I've got a few scenarios here, real world scenarios of graphs. We'll take a look at what the graphs look like in a second. But let's, for example, focus in here on number 2. Okay, number 2 says you're taking a pebble and you're going to shoot it vertically. Vertically means you're going to shoot it up into the air using a slingshot. The height of the pebble above the ground is the dependent variable and time is independent variable. Okay, so dependent, independent. What this is saying is that the height of the pebble is going to depend on how long it's been in the air. Okay, so if we're going to make a graph here, I want you to picture this. All right, here's our time, and here's the height of the pebble. Now, when you first shoot it, let's say you're standing here at time is 0, maybe the pebble starts off at your height, let's say it's 5 feet. Okay, the pebble starts here, you're going to shoot it up, but it's not going to go straight up, right? Because if it's going straight up, that's saying that it's instantly going higher with no time elapsed. But that's not really true. The pebble will climb as time passes. So it's going to look more like this. It's going to go up, and then at some point it's going to reach its highest, and then it's going to fall until it hits the ground. Okay, so this is what the graph might look like. And we say that this is the dependent variable, okay, because the height depends on time. Time is the independent variable. All right, so I mean, you look at this graph. Here, I'm going to show you a few of them, and you say, okay, now which one of those graphs best represents the pebble going up in the air? And you should be able to see that it's going to be this one. Okay, now I will for sure ask you on a test. I'll give you a scenario like that. Okay, let's pick another one here. I'll give you a scenario, and you'll have to draw the graph. Okay, so let's try the next one. It says here that you are purchasing flour from the bulk section. That means I can take as much flour as I want. I can take just a little scoop, or I can take a really big scoop. It says the cost is dependent on the weight. Okay, so let's go and look at these graphs. So this is saying that the more weight I have, the more it's going to cost. Okay, so take a look. Which one of these graphs do you think represents, right? On the bottom, we're going to have the weight, and we're going to have the cost over here. Which one looks like it could be correct? All right, this one is saying that as weight increases, cost goes down, so it's not that one. Well, this one looks like it's going up. Does that one make sense? I don't think so, because the curve would indicate that it's not going up at a consistent rate. And if you've ever bought something from the bulk section, the more you buy, the more you pay. It's consistent. It would be a straight line. Okay, so we're basically down to which one of these is it? Okay, and I hope it makes sense that it should be this one, because here this is saying if there is 0 weight, it's 0 cost. This is saying at 0 weight, it still costs something. I don't think that would be true. Okay, so this is what we're going to be spending a lot of time on, is looking at graphs like this. Let's today get into the lesson. Okay, so here's something new. Input, output. I want you to get used to thinking the input is X and the output is Y. So those are like synonymous. I can say input, output. I can say X, Y. All right, what is the rule that is taking me from here to here in each case? Don't say what's happening here. I want to know what is happening to get me from the input to the output. What is being done to the input that's going to take me to the output? Hopefully you can see that we're going to multiply X by 4, right? 2 times 4 is 8, 3 times 4 is 12, 5 times 4 would put me 20 here. That must mean this was 6, and this would be 28. Okay, I know it's really easy to try and say, oh, we're just going up 4 every time. I'd like you to try to avoid that scenario and look at how are we going across. Okay, so this one will be harder. What are we doing in each case to get from X to Y? Okay, I'll give you a second to look at that. I'm going to pause the video and you see if you can. So it's a little trickier. Lots of stuff going on here. I mean, the first response you might say, oh, it's just we got to add 1, but that doesn't work here. There's actually 2 things that are happening. We're going to multiply by half, or you could say divide by 2, and then we're going to add 1. Okay, so multiply 0 by a half, it's still 0, add 1, we get to 1. Multiply 2 by a half, you get 1, add 1, you get 2. Multiply 8 by a half, you get 4, plus 1, you get 5. So this would be multiplied by a half is 7, plus 1 would be 8. That means we must have had 20 here. No, wait, not 20, 40. And if I multiply this by half, I get 11, plus 1, it would be 12. Okay, I just wanted you to see that because of the idea that we have input-output. Okay, don't worry about the table. I'm not going to give you a table to figure out. More important that you understand this stuff. The domain, new word for you. Okay, we're going to say this is the X value. It's the set of the first elements in the relation. It is also called the input value. Okay, so the idea that we're putting something into the function, that's the X value. All right, on the other hand, the range is the Y value. It's the second set of elements in a relation. It's called the output, and it is the dependent variable. So we have the input, output, X, Y, domain and range. There's kind of synonymous terms. We will use them very frequently. All right, and now let's talk about what this idea of what a function is. A function is a special type of relation where each element in the domain is associated with exactly one element in the range. In other words, if one value in the domain gives 2 or more values in the range, then the relation is not a function. I always think of the function as some sort of a machine. You're putting stuff in, and the stuff that comes out has to be unique. Every input can only have one output. If there's more than one output for one input, it is not a function. Okay, so this is what we'll be focusing on in the next little while. So here's some examples of a function. If you remember to our first lesson, we talked about a relation. These are all relations, all of these here. What we want to do now is decide, are they functions? Okay, if it's a function, you should take an input, the X value, and it should have only one Y value. Okay, so take a look at this one. Here 2 becomes a 0, but 2 also becomes a 5. This tells you this is not a function. Okay, let's check the next one out. A 5 becomes a 3, a 4 becomes a 3. Oh, hang on a second. So 5 becomes a 3, 4 also becomes a 3. Does the input, here's my input, have a unique output? Yes, it only has one output. Okay, this is still a function. Okay, now I know this is seeming a little bit confusing to you. Let's do one more here. This might make it clearer. I think it's easier to look at it like this than it is to look at it like this. So look here. Here is my input. And I can see there are 2 arrows leaving the input. 2 different outputs. Right away, that tells you this is not a function. Okay. Now check this one out. Here is my input. How many arrows leaving? Just 1. My input. How many arrows leaving? Just 1. This one is a function. Each input has only one output. Okay, Now, we're going to do lots of these kind of questions, so don't worry if it's still a bit confusing. All right, now if you look at this, it also said if it is a function, we're supposed to do the domain and range. This is new. So let's list the domain and the range for the ones that are functions. All right, and anytime it's a finite set, in other words, I can list them all, I'm going to use these brackets. So I'm listing all of the domain. So I have 5, 4, -3, 0, and 3. There's the domain. Similarly, let's do the range. 3, 3, 3, 5, and -1. 3, 3, 3. I don't have to write it more than once. Those are my range values. Okay. Let's try another one here. The domain and the range. So it's a finite set. I'm going to list all of my domain. I have -5, -2, 0, 1, and 3. And for my range, I only have a 7. All right. Next, same kind of question. Identifying functions from a table of values. So it's just a different way to represent it, but we're still being asked the same question here. For each table of values, write the values in the table as a set of ordered pairs. If the relation is a function, determine the domain and range. Okay, first, ordered pairs. 2, 6, 5, -7, 2, 0, 1, 1, and -8, 5. There are my ordered pairs. Is this a function? Well, if you look, 2 becomes 6 and 2 becomes 0. This tells you not a function. Okay, let's try the next one. By the way, you guys, anytime I'm going through this work, I think you should always pause before the next question and try it yourself. Okay, and then I will do it with you. So let's list the ordered pairs. 4, 5, 6, -9, 5, 0, 3, 5, and 2, 5. All right, looking at the inputs and outputs, this is a function. Okay, so now we can do the domain and range. The domain is 4, 6, 5, 3, 2, just as easy as listing off the x values. And the range, oh, I don't need to write 5 again. There we go. Okay, pause the video, try these 3, and then we'll do them together. All right, there are your answers. You can see the first 2 are functions because each input has only one unique output. On the other hand, C, the 7 becomes a 3. It also becomes a 4, so that means not a function. All right, I'm going to stop there. Okay, for homework, you guys can do exercise 26 in your work package, and we will continue this lesson with the next video.